Hello students, welcome to the world of chemistry. This is Dr. Vikram Panchal and I will start thermodynamics. And in this topic, this is the first lecture and it is about thermodynamics. So first question is, what is thermodynamics? Okay, and the answer is, it is the study of chemical reactions or physical reaction with respect to time. There are two main important aspects of thermodynamics that we would like to know. That thermodynamics give us information whether reaction is possible or not. If any chemical reaction is going to be happen, whether it is possible or not, this information is available from thermodynamics. And second, very important information is available from this, that whether the reaction is endothermic or exothermic. That means during reaction, should we give energy or energy released? So this way, these two main important informations available from thermodynamics. That is why thermodynamics is very, very important. And whenever we study thermodynamics, it is always related to graph. So let us understand two different types of graph. The first one for endothermic reaction. Okay, so for endothermic reaction, let us say this is energy and here it is a progress of reaction. So for progress of reaction, how far the reaction goes, that we will have to see. So when any chemical reaction starts, it is always with reactants. So normally reactants give product. This is the common reaction. Now when we start any chemical reaction with reactants, reactants have certain amount of energy and that we do not know. So suppose some amount of energy of reactant has, and then this is converted into product. Before that we have to supply energy. So when we give energy to the system, energy of reactant goes on increasing with respect to progress of reaction. And then we will get intermediate state, or it is also known as activated complex. Okay, it is called activated complex, or it is in transition state. So once the reaction occurs in transition state, the amount of energy absorbed by the reactant is maximum and further energy cannot be absorbed by this, and this much energy is known as threshold energy of the system. Okay, now when this reactant is converted to product, again due to attraction, energy released, and energy released, that means energy of the compounds decreased. And now if energy released but that is less than energy given, like this, and product is somewhere here. Look, this is energy of reactant and here we have energy of product over here. So here we can say that energy of product is greater than energy of reactant, and therefore if we take difference of these two, which is called delta E, it is called EP minus ER, and this, as EP is greater than ER, this difference will be positive, and therefore this reaction is called endothermic reaction. So for any endothermic reaction, here we can say that energy given is more than energy released during bond formation. Okay, so because chemical change means breaking of bond, so we can say that breaking of bond requires more energy than when bonds are formed, energy released. So formation of bonds release less amount of energy, and therefore overall energy is given, and therefore it is endothermic reaction. For any endothermic reaction, energy difference is always positive. Okay, so this is regarding endothermic reaction. Now for exothermic reaction, let us see this one. Again we will draw a graph of progress of reaction versus energy versus progress of reaction. Okay. And here also the reaction is same, like reactant is converted into products. So for this reaction, let us start somewhere from here, and energy of reactant is this much. Let us call it ER. Now when the reaction is going on, energy of reactant increases because we have to break bond, and here we will achieve transition state. The energy of transition state or activated complex is called threshold energy. This is the highest amount of energy achieved by the chemical reactions, okay, in these compounds. Now when these reactants converted into product, they form a new bonds and then energy decrease. Suppose energy decreased is much more than energy given and product forms somewhere here, then this is energy of product. And here we can say that energy of product is less than energy of reactant. Now for this reaction, if we take the difference of energy of product and the energy of reactant, it is EP minus ER, and as EP is less than ER, this difference will be negative, and therefore it is called exothermic reaction. So for any exothermic reaction, the energy given for breaking of bond is less than energy released when bonds are formed. Okay, so here we can say that energy given for breaking of bond is always less than energy released when bonds are formed. Therefore, overall energy released during the bond formation, and therefore we can say that it is exothermic reaction. Okay, so this way it is exothermic reaction. So these are the main two aspects of any chemical reactions, whether reaction is endothermic or exothermic. Remember, EP cannot be equals to ER during any chemical change. Okay, so these are the two different things of thermodynamics. Now we go ahead. In thermodynamics we have to study certain laws. Okay, so we'll start with zeroth law of thermodynamics. This law is related to temperature. It gives us information about temperature of the system. Okay, so zeroth law is mainly related to temperature. Then we have first law of thermodynamics. First law of thermodynamics, which is mainly related to concept of energy conservation, or it defines internal energy, and the symbol of internal energy is E or capital E or capital U. Any one of this can be used. That means it is also considered as break-even law. Okay, then second law of thermodynamics. Second law of thermodynamics defines mainly concept of time. And possibility of reaction. So it mainly defines possibility of reaction. Whether reaction is possible or not, this we can understand from the second law of thermodynamics. It also gives the concept of entropy. The symbol of entropy is S, capital S, as well as concept of free energy. and free energy was defined by Gibbs, so it is given capital G for that. Okay, so these main two important aspects are obtained from second law of thermodynamics. Then we have third law of thermodynamics. Third law of thermodynamics sorry which explains us the numerical value to the entropy. So this gives us concept of numerical value of entropy, and it also explains us the concept of temperature scale. Kelvin and degree Celsius. It also gives us information about absolute temperature, that is 0 Kelvin, that is minus 273 degrees Celsius. Okay, so these all informations are available from thermodynamics. It is a general lecture where I have explained you all this thing in brief. In fact, we'll go ahead with all these laws in detail. Okay, thank you so much